let's start. I hope you can hear me. Is everything fine with sound? My name is Simona Bekeraite, and I'm here to talk about Technarium, a hackerspace in Vilnius, which we are doing with some colleagues. I'm actually an astrophysicist by trade. I research the properties of rotating galaxies, so in this conference I could probably pass as a data scientist. But I'm not here to talk about that. I'm here to talk about the physical space we do in Vilnius. I have questions. How many of you are Lithuanians, or at least live here? Oh, great to see so many people from abroad as well. Thanks for coming. So we are a hackerspace, and we are a very diverse place with a number of diverse people and diverse stuff we do. We do everything from coding to electronics to ceramics to metalwork to carpentry to 3D printing to biochemistry to gardening, whatever. And I'll talk a little bit about the history first. So we started off as a tiny basement in an underground of an illegal punk rock club in Vilnius. It was a small room. It was a nice, cozy room. I wrote my master's thesis there. But in any case, we couldn't fit more than 5 persons there. And when people and things couldn't stack anymore, we had to move out. So we moved into an empty, huge hangar in a former drill factory here in Vilnius. These were nice times as well, because we could fit in a car, a bus for repairs. You could fit in a party with a barbecue inside. You could do huge metalwork projects. We could light up a fire cannon. But, well, the city development caught up with us and we had to move out. Nowadays, we operate a 700 square meter space close to the center of Vilnius. It's located in a former industrial building. It's quite nice. Here are the premises. Obviously, that's how they looked before people and their stuff moved in, because they are pretty full now. And we are a non-profit. We have close to 50 members, and of course, many other people come to visit. We have a metalwork workshop with some welding equipment and metalwork tools. We had the workshop as well. As any vanilla hackerspace would do, we operate an electronics, computer, and 3D printing room. But as well, we also have a biochemistry lab. We have a ceramics and jewelry studio. We have metal casting equipment. We have some guys building unmanned aerial devices here. If you want to talk to them, we have people building a brewery. We have people building a photo lab and many other things. And why we do that? First of all, of course, we are a diverse bunch of people interested in different things. But I think the second reason is that Lithuania is a post-Soviet country, and in Soviet Union, like 25 or so years ago, people were forced to know how to build and how to make stuff. You wouldn't able to drive anywhere if you didn't know how to repair your car, and if you didn't attend to it every month. You wouldn't have anything to wear if you didn't know how to sew or mend clothes. You simply had to do it, and all consumer items came with complete schematics and instructions on how to fix it. It wasn't because the government thought it's cool to be a maker or something like that. The government didn't care. Just the quality of the stuff was so low that the consumer was expected to provide a lifetime warranty. And that's what people did. I'll show a few examples from our immediate surroundings. That's a kitchen knife that the father of one of our members made 30 years ago, and the knife still cuts. It's a bloody good knife. He made it at work and from stolen metal scrap. That's a potato grinder, which was designed and made by a neighbor. And that's probably the best potato grinder I've ever seen, because it's so easy to clean, it's so easy to operate and to maintain. It was made by a single guy after work in a basement, not by a hardware startup or something like that. So in Vilnius, we do have a big group of curious, smart, educated people who are not afraid to build stuff. The potential barrier between having an idea and deciding to work on it, to do it yourself, is much lower. However, what we do lack here are the communities of technical people. We don't meet. Everyone works in isolation in their own garage or a small room. And that actually leads to stagnation, that leads to isolation, and people don't exchange their knowledge. Therefore, the progress stops, and we don't know about latest development in the fields. Second, because in the Soviet Union, which came before us, of course, but you still remember, the this technical creativity was forced on us, people became lazy. They didn't actually want to build and to make stuff in most cases. They had to do it because otherwise it would be difficult for them to live. So people became happy with the simplest solution, with cheap hacks, with dirty solutions, with the ones which are simple to do but don't hold up well, so they don't strive for excellence. They are happy to live on duct tape for 50 years. And I think that's a problem. Of course, we try to change it. And that's not only us, that's also many other initiatives such as No Trolls Allowed Hacker Camp here in Lithuania, Vilnius Girls Code, Green Garage, even this conference. I think it has something to do with it. We do it in a number of ways. First of all, we try to educate the public. We invite people to come. We organize events. We embrace meetups of many sorts. We teach people. We do workshops. Actually, in a couple of weeks, we're doing a workshop called Arduino for programmers. That's for people who know how to code well, but who don't know what a data sheet is or what a pinout is. So yeah, come if you're interested. As a second thing, we share the stuff we do. And that not only means the code, but it means the schematics and blueprints for electronics. Even the blueprints for a house we built a couple of years ago, we shared. It's open. Anyone can use it. I'll talk about it a little bit later. And as a third thing, Technarium is a co-working space for freelancers of various kinds, of various professions. So, for example, we have carpenters who built an interior for a very nice bar here in Vilnius, and we have electronics folks who did the LED lighting in collaboration. Or this example, it's a variable speed programmable pulley, which was made also by two people. One did the metal work and engineering, mechanics, the other did programming. Moreover, we talk to people who have questions, and that happens quite often, because actually I see quite an interesting reversal. There is a lot of people who know how to use computers well. Computers are no magic for them. They are able to make a nice CAD drawing. They are able to make a nice 3D render. However, they have difficulties imagining how to turn their ideas into reality. It's a complete black box to them. They either think it's very easy or either think it's impossible at all. So we try to show them that there's no magic. You can do it. You can turn a computer drawing into a real thing. There's only you and a hammer of your preferred size. We also do another public service quite often that's called the Brick Wall Startup Accelerator. And probably because of the promise of Internet of Things and microprocessors, which are accessible, we now have an influx of hardware startups here in Lithuania. However, hardware is hard for a reason, because the development cycle is different. Basically, you manufacture things, you test things, you develop things in a whole different way. So that's not so easy. And I think it's a problem because most of the people who found hardware startups, they have a background in programming. And we, with the programmers, most of us spend most of our waking life in working in abstractions. So we lose touch with the physicality of the actual medium other than pure thought. It's a ceramic plate with the OpenSSH source code, which led to Heartbleed vulnerability. So we no longer know how to use physical medium and how to design for it. We try to help with it. And this problem is nowhere as acute as in 3D printing, because people come and try to print things which are better left unprinted or made using other means. Because most folks think that 3D printing is something magic. A 3D printer is not a box, it's not a machine, but it's a teleporter, which basically materializes stuff out of pure air. And it's not the case. It's a machine. It has its own physical properties. And it works with plastic. It deposits plastics. And plastic has its own physical properties as well. Everything matters. Speed of printing, layer deposition, temperature, many other factors. And even industrial services providers not often take care. They don't think of 3D printing as a material operation. They think it's a computer design and that's all. We try to work on this. And this all explains why we embrace crafts such as ceramics or fishing net mending or jewelry or metal casting, and which are entirely physical. They don't have much digital into them. They are of course affected and improved by new technologies, but they also let people keep touch with the actual matter they work with. Let's talk about electronics a little bit. Several people at the space have an impression that electronics, and especially the open hardware movement, which is currently exploding, is mostly recreational. It exists only for itself, mostly hobbies catering to other hobbies. And I think nowadays we have the same problem that the Soviet people had. We don't have access to good things we have to use every day. We don't have the equivalence of Linux or Apache, of the open source software. And good things are either very expensive or difficult to come by. So we thought we would try to contribute to the solution of this problem, and this thing shown here, and it's also at our stand at the room, it's an open source solid state relay, which is used to regulate the main voltage in many applications. This thing is a temperature controller. We made a batch of them, and it's open source, so people use it over the world. For example, one guy in the Netherlands is trying to make an open source crematorium to burn people remains, and he uses that. Also, there's a soil moisture sensor, which is currently being used in California for large-scale medical marijuana growing, and I think it's quite a beautiful development. Going down to simpler things, we also made some do-it-yourself LED lighting at the space because we had to light all this huge building, and we were looking for a working and affordable solution. So we collected some tribal fixture, we collected lots of LED strips, we did lots of soldering, and now we had lights and they work pretty well. You also can see them at our stand. It's very cheap, it works well, it's better than the daylight. Now let me wrap up with some simple things we also made, or not so simple, but still not so serious and important as the ones I've mentioned before. And that's a water wheel, not only a water wheel, but a full-scale micro power plant we built in the countryside over a small rivulet in Lithuania. And when we counted how much electricity it yields, it provides just enough power to light up 2 lanterns made with LEDs. Nevertheless, when we counted how much did it cost, how long we expected to operate, and how much power it provides, it's basically the most expensive electricity in Lithuania. It's more expensive than nuclear power or wind power, whatever. But still, it was fun. We learned a lot. That's a coffee roaster one guy made from an old washing machine. He took it apart, he cleaned it with fire, he welded things, he added a drive, a motor, but it works. It worked beautifully. That's one evening we had hackerspace hacking, and someone wrote a shell script which just compresses images before uploading to the internet. And then he ran this script for a number of times on the Lana image, and that's what happened. It's just educational, but we had fun doing it, and I think that's a pure beauty of doing things. And the last one I want to show. It's a 3D printer which had a pencil taped to it, to the extruder, and it was drawing mathematically generated drawings, binary trees, which you could do yourself generated. And the nice thing about this project I like is that it has a line in the code in which there's a constant which accounts for the use of pencil, or for the use of graphite. So the head of the extruder moves down a little bit after a certain amount of drawing. Yeah, it's all open source as well. So with that, I'd like to finish. I was given an hour to talk, but of course, that was unexpected for me as well. And I hope you can see some other talks later. If you are still in Vilnius, or if you are from Vilnius, we'd like to invite you to come to the Hack and Tell event, which is just a meeting of creative people where you have to show your project for 5 minutes. You get asked questions. You can win a prize. And the next one is on the 27th of November. So I hope to see you there, or to see you at our space at some other time, or to meet you here or online. Thank you. Yeah, and if you have any questions, feel free to ask me now or later. Mm, actually depends mostly, but yeah. Yeah, sure. For metalwork, you have to take a course. Well, it's just free for members, of course. So we train people to do stuff because it's dangerous for you, it's dangerous for your projects, and it's dangerous to other people. Sure.